Good afternoon, everyone, and welcome to the virtual learning course, Understanding the Unknown. My name is Sarah Snavely with Timmons Group, and I will be moderating today's session. Just a few housekeeping items before we get started. This program will last about 60 minutes, including Q&A. If you have questions at any point during today's presentation, you can submit them via the Q&A button at the bottom of your screen. This program is provided both via audio and web conference, so it will be recorded. And please note that this presentation is worth 1 AIA HSW credit. All certificates of completion will be sent out via email to all attendees. And now, if you've been wondering about geotechnical issues within design and construction related to identifying and remediating unsuitable soils on a project, you've come to the right place. It is my pleasure to now introduce today's speaker for today, Donald Smith with Timmons Group. Donald, take it away.
All right, hi everybody. I hope, like Sarah said, I hope the weather isn't too bad where you are. I've been with Timmons like 3 years here in the South Lake office, and I work with Nathan to kind of corral the geotech and CMT work here. And today we're going to talk about understanding the unknown. First, kind of go over what the course is about, what the takeaways should be, understanding the geotechnical engineering study and what it consists of, and why we decide where borings go, and what can be done to expand the study. And then, the big thing is identifying issues that come up during construction, how they can be identified during design and prior to actually go into discussion, and then we'll finish with some Q&A. So the big thing the course is, what we want to, this was initially geared towards the architects, and is basically like, everybody knows that it costs more to rectify something once the design is complete, the contract has been awarded, and boots are on the ground. So what we're trying to do is educate everyone about what's in a geotech report, what to look for, and that way you can walk away with enough information to ask questions during design, and then also during construction if issues come up. Is this the best solution? Are there other alternatives? Things like that. So the takeaways we would like is to understand how the location and the number of borings are determined in a study, how conducting additional site investigation techniques can reduce risk in soil remediation during construction. Learn the causes of unsuitable subgrades in soils, how you can identify them, and then how you can remedy them during construction. And then develop enough understanding so you can ask questions. That's the biggest thing, is you're not going to walk away from this being an expert, but you will get some takeaways that hopefully somebody says something in the future and it'll trigger, oh, I heard this in our presentation, and you can ask a question that can cause them to maybe provide more information or an alternative. So what's in a report? We talk about the subsurface exploration, the laboratory results, any analysis that are done, recommendations based on those analysis, and then the construction considerations. I always point to construction considerations and the geotechnical recommendations. The recommendations are basically based on what we've seen in the field, and this is what we recommend, foundation-wise or retaining wall-wise or pavement section-wise. But the considerations are taking the recommendations a step further, and these are the items that may come up during construction that are probably going to cost the owner money, whether it's dewatering, unsuitable soils, the presence of rock higher than a bearing grade or an excavation grade, things of that nature. Are you going to have issues environmentally? Is there a big trash pit on the site? So the subsurface exploration, it basically we come in and we get samples, and we'll get test borings done, sometimes test pits, and in some cases we'll do a little further testing with pressure meter, CMT, DMT, depending on the type of foundations we think are going to be on a project. And it pretty much it helps us just establish the properties of the soil. And what we provide is, I'll show you later, is basically like a graph, and it shows, you have fill here, this type of soil here, this type of soil here, and that's where we draw our geotechnical recommendations from. So how we attain our borings in the soil samples is with the standard penetration test. So this right here is either 18 inches or 2 feet long, and it's only 2 inches in inside diameter. So if we put 10 holes on a site, 10 borings on a site, we're only getting 2 inches of soil sample within each one of those holes. So if your site is, 100 by 100, you're really still not getting that much information from the samples. There's a lot of variability. There can be a lot of variability, but this actual test is where we get our N values from, and we use the N values to correlate soil strength. And then we take the soil that's inside of the cone and put it in jars, and that's where we get our samples from. So this is kind of what I was speaking about, the stratigraphy. This is an important page on the geotech report because it lists the elevations, and then you can see the type of material. So say that we were here, and this is our footing bearing grade. So we can see the variation across the site of where the foundations will be, what they'll be sitting on. So some of these soils may be suitable, some of them won't be, but this kind of gives you a visual representation of that. The results of the test boring in the field are presented on a test boring log. So there we classify the material, we provide any lab data pertinent to that material. We list the depth and elevation where the materials are encountered. It also has their stratigraphy on there. The results of the SPT test, which is the N value associated with each type of material, and groundwater observation. So we may, at 10 feet, you may see a little indicator saying that, groundwater was observed at 10 feet. So this is an example. On this particular boring, you can see that we had sandy fat clays above sandy lean clays, and then we changed from a fine grain material to coarse grain materials, and then we got more fine grain materials below that. And so that this graphic here relates back to the page you saw before. You got the depth and elevation listed. The N values are right here. They're listed here. And then this is the test results, the liquid limit and plastic limit that we observed in the lab. And up here, where we'll list any groundwater observations and anything like if it caves, which is pretty common. So laboratory testing. Typical laboratory tests from boring, content gradation analysis, Atterberg limits. These are the things that we use to classify the soil that we get from the SPT test. Other tests that we perform are, we'll get a bulk sample from the top 5 feet, and we can run a Proctor or CBR from that as well. But these are the bread and butter. These tests right here provide the bulk of the information for our engineering analysis and geotechnical recommendations later on. So the components, the introduction, data collection and analysis. So the introduction is what we understand the project to be. Data collection and analysis is how we approach the site, what we did on site to collect data, and what we plan on doing. The recommendation is based on the lab results and everything that we get back, and that'll be where foundation recommendations are made, retaining wall, pavement. Construction considerations are already discussed. That these items are basically, this is what's going to cost you money during construction. The limitations, we'll set limitations. We didn't drill this because of this, or we didn't do any environmental testing, that type of thing. And then the appendices is just where we put all the lab data and boring log, location plan, all that stuff goes in the appendix. So the introduction. To me, the biggest thing is, and I've seen this happen in industry, where this first section, you're telling the owner, the architect, the designers that you understand what the project is and what they plan on doing on the site. So you may say it's a 5-acre site. The building will be in the northwest corner. It'll have a 90-space parking lot with a underwater detention system within the parking lot. And there's going to be a dumpster pad to the northwest and a new access road to the south. If you list all those things, then that's what you think the project is, and it's really a school edition, then, did you do a bad job copy and pasting, or, are you providing information for the wrong job? So it doesn't happen that often, and normally it is just some copy and paste error from before, but when reviewing geotechnical reports from others, I have seen where, they're talking about retail space, and it was for a community center. So, obviously those are two separate things, and that needs to be clarified before you can really take anything further in the report as at face value. So the data collection, we described all the strata encountered, existing fill, the different fine and coarse grain soils, what their geological origins are, what the properties associated with those different strata are, whether this strata is probable for a shrink swell, has a high probability for a shrink swell, or an existing fill strata that has a lot of organics that may need to be removed or may decompose over time and be an issue. And also, where we observe groundwater and what impact that has on the project. The recommendations. So we've gone out to the site, we've drilled it, we've run all the labs, we've got our results back. Now it's time to provide the recommendations. We're going to, in this section, talk about any recommendations for earthwork. A typical recommendation that all geotechnical engineers make, and it's not always followed, is all earthwork should be performed in the drier months. That doesn't always happen, depending on funding or timing or permitting or whatever. Project starts where it starts, but sometimes because this doesn't happen, the owner ends up paying more to get the earthwork done on a project, just because you're dealing with rain or cold weather or whatever. We'll recommend a foundation type, whether it's shallow spread footings or some kind of deep foundation as piles or drilled shafts. Any below grade retaining walls for basements, and any pavement recommendations that are required will go in our recommendations section. So earthwork recommendations. This is where we talk about what needs to be done to prep the site for earthwork. How much topsoil we observed. What if there's a compacted fill that needs to be imported or excavated and placed on site. What the suitable materials are for that, how thick that those materials shall be placed, and then any compaction requirements that are associated with the testing of the fill. And then a moisture content requirement. Some projects, there's a very strict range. A lot of times you just see where you just want the material to be able to achieve compaction. So you have a certain window based on the Proctor value that the moisture content needs to be. Spread footings, we'll talk about the allowable bearing pressure of the soil, what we anticipate the bearing soil to be based on our borings. I go back to the stratigraphy graphic that kind of showed like an elevation, and you can see the varying types of soil. Some of those soils may not be suitable. So in this section, we'll say, the footing subgrades in the eastern portion of the building pad will be bearing on a high plastic material, and they need to be lowered an additional 2 feet. And that kind of goes into the next thing, which is the frost depth for the area. All footings should be below the frost depth. And then any shrink swell issues that come from that, the change in moisture of the soil over time can destroy the concrete. And then everything settles. And in this section, we'll talk about the expected differential settlement across the site based on the type of materials we observed, the lab testing that we observe in those results, and what the anticipated bearing strata will be for those foundations. If the spread footings on a solution and we need to go to driven piles, we'll recommend a pile type and size. We'll also discuss the allowable capacity and what we anticipate the tip grades to be based on our data. Any issues with installation, there may be a site with a bunch of existing fill, and you know that it's 10 feet of existing fill and you had trouble getting your borings done and getting a boring through that level. So, you know that there could be some issues with that. And depending on the type of pile you're driving, stresses can be a huge hindrance to getting the pile installed properly. And so you may say, we recommend that the contractor, pre-drill all holes at pile locations to a depth of 10 feet below subgrade. And that way you're just augering through what you think the junk is. Any testing requirements, all piles have to be tested for their capacity, what the anticipated capacity is calculated to be. The most common method for that is dynamic pile testing, which is PDA. It's more widely accepted now. It used to be a either or type thing. It was a big deal to recommend PDA testing in the geotech report. It's pretty much a commonplace now. And then once again, any expected settlements, just because you're putting a building or parking garage or something on piles, you're still going to have differential settlement across the site. Drill shafts are the same way. The type and the size. What the anticipated bearing material is, whether it's a type of soil, we're looking for maybe a particular geologic formation to bear these in, or we're going to rock, and we'll discuss what competent rock is here. The bearing pressures associated with those bearing materials, and any shaft friction. Some piles have friction in the calculation, and so we'll talk about that. And then once again, the bearing grades, where we're thinking it's going to be, in any installation issues. With drill shafts, groundwater can be a huge problem, and so if you observe groundwater pretty high, then the installer is going to anticipate the use of a slurry mix or something to get the concrete in for the drill shaft. That's an additional cost. If that's something that's mentioned ahead of time, then that would be included in their bid price. If it's neglected during the geotech report, or the designer does not pick up on it, then it may not be a requirement in the bid package, and then they'll come back and say, hey, this is additional work, we need more money. Like I said, construction considerations. So we've got all this stuff that we've kind of analyzed and reported on, and the information is, this is what we think you need to do to properly support everything that's going on the site. However, your site has X, Y, and Z, and you need to take these things into consideration so that you can do what you're planning on doing. Whether that's, maybe in the parking lot area, there's copious amounts of topsoil, and so you don't the topsoil right under your parking lot or right under your entrance road. So that's going to require some additional excavation by the earthwork contractor. And basically this allows them the opportunity to come up with some kind of preventative method, whether they just term the site an at-risk site, and the earthwork contractor is responsible for everything below the subgrade. They're going to price it as such, or maybe you have some contingency built into the bids, and you'll ask for an allowance for undercut. You may say, we anticipate 10,000 yards of undercut on this site. What's your price per cubic yard? And that becomes a way that the bids are analyzed. Typically, when they're bidding undercut, the price is going to be cheaper than when they already have the job and they're on site and mobilized. So, you know, bidding undercut, they may find a cheaper supply to get the proper material. They're going to take a little bit of a hit on the labor costs. After construction, they're going to, you know, it may be $35, $40 a yard to undercut and replace. And during construction, it might be $55 a yard. Very rarely have I seen an owner contract a different company to come in and undercut something. You just don't see that. So that just helps them save money. Like I said, you know, this area, this is a section where, you know, I like to draw the most attention to for architects or for CA people to say, hey, look, this is where we're saying we've done the analysis, we've taken all the information available into account, and we feel that these are the areas where your owner is most at risk to complete their project. So how do we decide the quantity, depths, and the locations of borings? Sometimes we get a phone call and the owner insists that they only want 5 borings on their site, and this is how deep they want them, and they've, you know, done hundreds of these projects that they know, and sometimes they're right, sometimes they're wrong. A lot of times, you know, we just like to say, like, let us decide how many borings, and, you know, we'll cover the site as best as possible. A good rule of thumb is 1 boring every 200 feet. If you have experience in the area and you anticipate high variability, you may drop that to 1 every 100 or 1 every 50. It just kind of depends on what your knowledge of the location is and what you think, what is below the ground surface. I put this equation in there just because it was something that I picked up on in college, and I don't know, I've never used it, but it's just 10 times the number of stories to the 7/10th power. Footing depth is the boring depth calculation, but that's not typically determined. Excuse me, the big thing is that when you call somebody, you know, whether it's us or somebody else, that you call them to just discuss the project in general with information. Maybe you have some loads, maybe you don't, and then let them plot out how they're going to attack the subsurface exploration. That's the biggest takeaway from this, is let the professional do what they need to do. And non-building borings is typically dictated by an asphalt section, the amount of fill, whether you have some ENS stuff on site that needs information. Pavement borings, you always want to go to the deepest utility just to make sure that you have enough information to know that you're not going to have any issues with your utilities settling, being founded on extremely soft soils, or that groundwater or rock won't be an issue to get your utilities installed. Similar spacing is the borings, you know, 1 every 200 feet, unless you have previous knowledge of some conditions. Any permanent BMPs or underground retention systems, you're going to want information on. Large fill areas, you're going to want some information on, and also large cut areas. We'll do borings on cut areas so that you can get the information and know what you're digging out to place over here. And typically we'll run a couple proctors on those borings as well, so that you already have information related to what the in-place moisture is of that material, and you'll have a proctor value of that material. So when it's time to place it, you're not waiting on lab results. And then also any retaining walls that are on site, they have foundations that they need supported by soil. And then any slope stabilities where slope may be an issue. Your building is going to be next to a slope. You'll want to do a slope analysis on that. When additional recommendations or site investigation are recommended. So we've done everything. We've written our report, and within the construction considerations, or maybe even the recommendations, we'll say like, hey, we found X, and to limit your exposure, there may be environmental concerns. Maybe a boring had the smell of petroleum, or maybe you saw trash or a bunch of organic material in a boring at a depth that's going to be a hindrance to what's going on that part of the site. Or maybe you had some obstructions and you couldn't get this boring done because you had obstructions on site. You'll want to incorporate this information in the report so that the owner has more information. But we, like I said, we only have the 2-inch diameter sample. So, we need to see more so that we can kind of identify these areas and come up with a contingency for the owner so that they have an idea of what these additional costs are going to be up front. Also, if anything on the site changes from when the geotech is given a site layout plan and they determine this is where everything is going to be, to when the plans are sent out for bid, if anything changes, please, I implore you to just circle back to the geotech and make sure that everything's fine. Anecdotally, I was working on a project from one of the localities here several years ago for another company. We drilled the site. We identified this area that they were going to have to deal with for parking lot, and apparently they got a little bit more money funding than they thought, so they turned the building 90 degrees and expanded it. So not only did they turn the building and put half of the building where this trash area, the part that the extra 25 feet that they tacked on was also in this trash area. And nobody notified us of the change. We show up on site to proof roll for the building pad for them to put fill down. And, we anticipated there were going to be some spots in the parking lot area. Technician calls me and says, hey, we're in the building and I'm digging up trash. Like, we proof rolled, it was bad, and there's, 10 feet of trash. We already knew it was there, but I was like, you sure they're in the right spot? Yeah, it's been surveyed within the building limits. I go out there and they've rotated, they've changed the whole building layout, never contacted us, never circled back or anything. So needless to say, the money that they thought they had extra and spending it on the additional building size, they ended up spending a lot more than they anticipated on dealing with the trash in the parking lot. It tripled what their allowance was. I think the initial allowance was like $50,000 and ended up being like $150,000, $190,000 change order just to deal with the building pad. Also, what happened is they changed the stormwater system and put a on-site underground detention system under the parking lot. Initially, there was going to be a BMP, but then they decided to put like a gazebo right there. And so they changed all that and had to lower the utilities. So the utilities went from 3.5 feet in the ground to 7 feet in the ground at the deepest utility. And we notified them in the geotech report that we observed perched groundwater at 5 feet. So they had to deal with groundwater coming into their utility excavations and ended up over excavating all the utilities and putting open graded stone under them so that they had a suitable subgrade to bear on. So that was two things on one project where, a simple email would have invoked a discussion to say, hey, well, if you're going to do this, then you're going to have to think about these things and, what are the costs going to be? And they may not have decided to, flip the building, or they maybe would have done something differently with the money. I don't know. But, that's just one of those things, like if something changes on a site, you definitely want to let the geotechnical engineer at least take a look at what's being changed, and they may have some real concerns. So, you determine you need additional site investigation. Well, what do you do? We can always do more borings. Hand augers are just person's doing the boring instead of a mechanical auger. Test pits are also effective. You get a big excavator out there and dig some holes in the ground. Or maybe you need to do more lab testing. Maybe you need to do some environmental testing because, like I said, you've found some petroleum smelling material and you're trying to find the limits of that material so that you can, do what you need to do to submit to the state. And then, infiltration testing. Do you have to have a wet pond somewhere and you got sand at the bottom of it, then it's not going to hold water, or vice versa, right? You need that. That's additional testing that's not always thought of at the time of site layout and may come up later. So the benefits, like I said, you get more information. It helps you help the owner determine another item for them to budget and get a bid on, a competitive bid versus, we've already awarded a contract and the contractor just says, this is what it costs for us to do this. You can isolate areas of concern, establish limits ahead of time. And it also allows you to kind of re-engineer, well, maybe it's not the best to put the building right here because of these concerns. If we can put it on the other side of the site, how does that affect everything? It's something to be evaluated at that time when it's a lot cheaper just to pay a consultant, a designer to redraw some plans than it is to pay a contractor to haul off 30,000 yards of material. So how do you identify unsuitable soils during construction? Proof roll is the tried and true method. You either use a tandem axle dump truck that's not always available, or you may have suspicions that the material won't support a street truck driving over it. So you can allow them to use a pan or some kind of heavy off-road equipment, motor grader, off-road dumper, are typically what you want to see. Sometimes they only have a roller on site. That's a little more, I don't know, you probably don't want to use a roller, but I've definitely used a roller in my career because that was the only thing that was available. You're just more conservative when observing that. But that's what you do. You come on site and you proof roll. The contractor says, I stripped all the topsoil off. I'm ready to start earthwork. So you come out there and you proof roll what they've done to make sure that the subgrade is able to support whatever is going in the area. So like I said, if the subgrades don't exhibit significant movement, then the subgrades are good. If you get movement, which is pumping or rutting, then you need to do a little bit more work to evaluate the costs. So pumping is like a wave-like action. So you kind of think of this under the tire as the tire goes by. And so this is like a good video that shows pumping. So this is a job site. It's pretty sandy material. It rained the night before. You can see that the earthwork contractor wanted to put another lift to fill on there, and we recommended not to. They said, "No, it's fine. It looks dry." And then we get out there, and this is what it looks like. See how spongy that is? That's probably the best definition of pumping I can provide. And then so rutting. This is what rutting is. Basically the surface of the material is not strong enough to support the load, so it just sinks and gives in. And so a lot of times you get pumping and rutting as a combination in that. So pumping shows that you have some kind of issue below what you can see. Rutting's telling you that at least the surface is weak. When you have them both, excuse me, when you have them both, that means that the top layer is weak and you have some issue going on below what you can see. So typically we'll dig a test pit, and it's normally pretty clear why. Sometimes you may not be able to do a test pit, and we'll have to do some hand augers in that area. Typically the causes of pumping are some kind of perched groundwater, unsuitable material, maybe a loose fill. or maybe a wet fill, existing fill. But it's something dealing with water or organics or a loose fill, and the material above it has crusted over and dried out. And so, you get this pumping. And then when they pumping and running, you're probably going to have a dry material that's too dry to support the load. And then it's underlined by a material that's probably too wet to support it. So you get a wave action and the tire sinks as well. Other things to look for during construction to help you identify possible unsuitable material, any seepage. If you got water coming in from somewhere that you anticipate, that's always an issue. Utilities, existing utilities. The fact of the matter is that most of the time when utilities are installed, nobody's monitoring them, especially if it's not going under a known structure and it's going through a green area or next to a road or something like that. Typically those things are just, the material's just thrown back in there. If you encounter any existing foundations or evidence of mining activity, that can lead to, if it's existing foundations, then there was probably a building that was demolished, and they may or may not have cleared out all the construction, all the debris from that, all the trash from that, or they may have just demoed it and it demoed into itself, and then you're finding some kind of part of the building that's remaining. Mining activity here in Virginia, Henrico County, they built the school in the West End, and they were probably 85% done with the project. In that area, there were known areas of exploratory coal mine shafts. Prior to this school being built, we identified 2 during the phase 1 ESA on the complete opposite end of the site, but nothing on this side of the site and nothing else around it. Get through construction, they're finishing up the football field. They run the sod over it on a Friday. Everybody comes back on a Monday, and the middle of the 50-yard line of the football field is settled a foot. So you gotta think, nothing happened over the weekend. There was no equipment left on the middle of the field. It was just a football field, and when you walked, it was like 75-foot diameter. It went down a foot. We had no clue why. We ended up doing a couple borings in the middle of the circle of the depression, and just happened to find everything looked great. All the material looked as what you would expect a natural material to look like. It was very clean, no true evidence of it being existing fill. And our field guy was given the direction to go 60 feet and stop. And in the second hole that we did, he went to, I think it was around 45, 46 feet in the ground and found a piece of wood. So naturally, you're not going to find wood that deep. So everything above that was fill. And they ended up just kind of like putting this foam in to raise the elevation of the field. And they haven't had any issues since, but it was baffling initially to show up on a job site to see a huge depression formed, and everything seemed to be fine prior to that. We didn't have any issues with any of the soil around the track for the stands, for the concession stand, for the ticket booth, nothing. Everything was fine. We just happened to, I guess, it was enough traffic over it with laying the sod and installing the sprinklers and stuff that it decided to settle. I don't know. It was weird, but that happens. So corrective actions to pumping and rutting. You can improve the soils in place. You can remove the unsuitable soils. You can use some kind of geotextile or implement a bridge lift, or depending on what it is, maybe just create a working platform. So when you have a weak subgrade, sometimes you can just recompact it, right? So we did a proof roll and all we observed was rutting, then we'll just tell the contractor like, hey, just blade this off and bring your roller in and re-roll it. Just roll it again till it becomes suitable. Normally that's only up to about a foot or so that you can do that, and the moisture content must be sufficient to achieve proper compaction. It can't be too dry, it can't be too wet. We can also use lime or cement to treat the soil that's on top, the in situ soil, to dry it back and recompact it. This is normally when it's too wet. These are typically implemented in the winter months when you don't have an opportunity to dry soil, and because you don't have any days, the sun's not out, it's not hot enough, probably don't have the time, you're probably dealing with weather, so there's no to actually say we're just going to let it dry is not a feasible action due to the schedule. So what you'll do is you'll treat it with lime or cement, and it basically dries it out. It changes the properties of the soil some, and you have to run some additional lab testing, but you can save a lot of time and or money. It may be a large area, and to undercut it might be $25 a yard. To lime or cement treat it might be $9 a yard. So you get a good product and you save the owner money by doing that. Removing is undercutting. So if you remember that picture with the rutting, this is a picture where we removed what we deemed unsuitable. And you basically just get a piece of equipment and you dig down to what we determine as the suitable grade, and then they'll come back and they'll bring in a suitable material to place as fill. Another option is a bridge lift. It's used in areas of deep fills for non-building areas. So you don't want to put a bridge lift under a building, but basically you're putting a thicker than normal lift down to kind of bridge over some weaker subgrade areas. If the whole area is weak, then a bridge lift probably isn't going to work. But if you have some decent areas and some better areas and some better areas, then you can kind of spread a thick lift over it and roll it in, and it kind of you're distancing the load from the weaker area. Is probably the best way to explain it. But you've got two areas that are decent and you've got a weak area in the middle. So you just come in. A typical lift of fill is a maximum of a foot. You'd like to see the contractor place it in maybe 10-inch lifts or so. A bridge lift is 1.5 feet to 2. I've seen 3-foot bridge lifts used before, depending on how bad it was and what we were doing. But you want to use, when you place a bridge lift, you don't want the bridge lift material to be questionable material. You want it to be of a good moisture content, a good type of material. You wouldn't want to use a highly plastic, fine grain material that has a high moisture content for a bridge lift, because typically that's the type of material you're going to be bridging over. You wouldn't want to put the same type of material in place. You're going to want to use something more coarse, something that's sandy, maybe a rock screening or a 21 stone in that instance. You can also implement geotextiles. You can have a fabric like this, or you also have geogrid. Geogrid works best with stone. It allows the pieces of stone to lock into the openings, and fabric is also a good bridging tool. So this is how geotextiles work. You've got the geotextile, you've got the load from your vehicle going through the stone, and so instead of it just hitting directly in that area, it spreads across the geotextile before the load transitions to the soil subgrade. So it helps reduce the actual load that the subgrade sees, and in essence strengthens the subgrade And GeoGrid works the exact same way. A working platform, you typically see this in like a utility. Maybe you have groundwater issues or a very soft soil that doesn't seem to end. Like out at the Richmond airport, you have about 3.5 feet of existing fill and natural material that's kind of decent. And then below that, you have a very nasty fat clay material. So a lot of times if the utilities are going to be any deeper than that, then the civil designers out there will go with a thicker than normal stone bedding just to make it part of the contract, because you know that you're going to need that additional stone so that the pipe won't settle. But this is what that is illustrating. So you have a weak subgrade. You could use a geotextile if you want, or sometimes you just come in with a bunch of crushed stone. Just depends on the situation. To bridge or not to bridge, like I said, bridge lifts, geotextiles, working platforms are great to help move along earthwork operations. Is it advisable to always use them? No. You don't. If you have materials that are weaker, that you think are going to be unsuitable, you want to remove them within a building, or extend the foundation below that elevation, because in those areas you're going to have a constant load on that material. And so bridge lifts and stuff work best on pavement areas, parking lots, things where it's not a constant static load sitting on it. It's a dynamic load, like a car or a dump truck, something driving over it. So this is just indicating this. If you leave a weak soil under a foundation, you have your fill, you have your weak soil. Well, while this footing's sitting on it, the load is dropping, is going to go from the fill to the weak soil to the strong soil, and the weak soil will compress. And so you'll get some settlement below that footing. Now, if that is not uniform, which typically it's not, then you're going to get differential settlement, and that's going to show cracks are going to happen. Slabs will fail, doors won't be able to close. Sometimes whole buildings shift depending on how much it settles. And with that, any questions?
While we're waiting for some questions to roll in here, just a reminder to everybody that we will be sending out a certificate of completion to all the attendees. If you are a registered architect and do require credit to AIA and did not submit your AIA number upon registration, go ahead and shoot me an email and I will get that taken care of for you. And just another reminder, we do have more presentations coming down the pipeline. You can feel free to register for them at our website at www.simmons.com. Haven't seen any questions come in yet. I think we're good.
All right.
If anybody has any other questions, thank you, Donald, for all that information. And thanks for everyone attending today. We really appreciate it. If you have any questions later on, feel free to email myself or Donald, and we'll get those taken care of for you. And hope everyone has a great rest of the week.
Sure.
Bye, everyone.
All right, take care.
We do have one question if you want to answer it.
Sure.
In the case study, you mentioned about the sinking football field.
Mm-hmm.
Who took the liability on that one?
The county is that paying for it. Nobody, the contractor didn't do anything wrong. We couldn't determine they purchased the property from an old farm. It was old farmland, so they couldn't go back and say, hey, you didn't tell us about this. The farm, they may not even have known, because in Henrico they documented a lot of these exploratory holes. There's just wasn't one that made it on their map, and we suspected that that's what the case was, but when you get 20 or 30 feet in the ground and everything looks good, you're starting to scratch your head. So finding that piece of wood kind of was like a aha moment and felt good for everybody. But ultimately the county paid to have the football field raised.
Okay. We have another one here. Are geogrids a possible solution to recurrent full depth cracking of an asphalt tennis court?
It can be. It depends on partly what is causing the cracks. And so that would be something that, would need to be evaluated independently. It's kind of tough to say as a carte blanche, like GeoGrid will do this. Each situation is different and has a different reason why you're getting some failure. But it could be a possibility that's a solution, yes.
Okay. Anybody have any other questions? I think we'll wrap it up there then.
All right.
Thanks, Donald. Thanks,
Take care.
everyone, for attending. Have a good one.
All right, bye.
Bye now.